help us with the exact values of our angles in trigonometry, it's important that we rationalise the surds. Now a surd is an irrational number. It's a number that is non-recurring, that has an infinite number of decimals after it. There's no pattern, there's nothing that exists, and so we call that a surd. An example of a surd is root 2. Root 2 is approximately 1.41. It keeps going, has no reoccurring whatsoever. Well, when we use surds, we want to be able to do a few things with them. First, we want to be able to simplify a surd. So say I had the surd square root of 18. To simplify that, I need to think to myself, what are two numbers that multiply together to give me 18? Well, there are lots of them, but the key here is to find one of or both of those numbers to be perfect squares. So your perfect squares are numbers like 1, 4, 9, 16, 25, etc, etc. Well, in this situation, I have that that's 2 times 9. 2 times 9 is 18, and 9 is a perfect square. I can take that surd now and separate it out. The square root of 2 times the square root of 9. The square root of 9 I know is 3, so this ends up being 3 times the square root of 2, and that is simplified. What I want to be able to do also is what we call rationalise the denominator. Now if I had a fraction where the denominator on the bottom was a surd, I don't really want that to happen, because that's a bit of a strange situation or difficult situation to get an approximate value for. So what I need to do instead is to rationalise that. So the way I rationalise it is I look to see what this surd is, and I multiply this entire fraction by another fraction, which is that surd, root 3, divided by root 3. Well, this is just 1. And anything times 1 is just itself, so I haven't actually changed my answer whatsoever. If I multiply like I would fractions, so the two numerators together, 5 root 3, and the two denominators together, 2 times root 3 times root 3, I can see that if I have root 3 times root 3, that's the same as root 3 squared, which is 3. And 2 times 3 in this case is 6. 5 root 3, and that is my surd now rationalised. If I have a look at another example, such as here, this is a little bit different. I can't just multiply this fraction by one surd over another surd, because I have it as 1 plus root 3 on the bottom, and I'd still end up with a surd on the bottom. But if I think back to completing the square, and in fact the difference of squares is what we like to call it, if I was to multiply this by 1 take root 3 on 1 take root 3, when I multiply this out now, I get on the top line that's just 1 take root 3. On the bottom line I end up with 1 plus root 3, 1 take root 3. And this is the difference of two squares on the bottom there. And if you remember your difference of two squares, that's 1 times 1 is 1. Root 3 times negative root 3 is negative 3. And the answer I get is 1 take square root of 3 all on minus 2, or the negative of that.